Hello dear students, good morning. Today we will discuss about the chapter wave. Already we have discussed what is the meaning of wave and the classification of wave. Once again I will repeat for those who have not watched the first video. So first of all, the wave is the disturbance made in the medium is called as wave. Disturbance in the medium is called as wave. Then on the basis of medium, on the basis of vibration and on the basis of dimension, we can divide the waves in three types. That is on the basis of medium, on the basis of vibration, and last on the basis of dimension. So the first we discussed in last class, that is based on the medium. Based on medium, the waves can be classified into two types, and that is mechanical wave and non-mechanical wave. Mechanical waves are those which require material medium for their propagation. Propagation means motion of wave. That means wave is moving. That is called as wave propagation. And the next is the wave which does not require medium for the propagation is called as non-mechanical waves. The wave which require medium is called as mechanical wave, and the wave which does not require medium, that is called as non-mechanical wave. So in today's class we will discuss the further classification of wave, that is based on their vibrations. Based on vibration, waves can be classified in two types. That is, first one I will write here based on vibration. This is very important. Based on vibration, we can divide or we can classify the waves in two categories. That is, the first one is I write here transverse waves, and the second one is longitudinal wave. I hope you can see that. The first type of wave which is based on vibration, that is transverse wave, and the second one is longitudinal wave. Very important. They may ask for 2 marks. On the basis of vibrations, how waves are classified. Then the waves are classified on the basis of vibration in two types. Those are transverse wave and longitudinal wave. Very simple. They may carry 2 marks. Okay, or they may ask what is transverse wave or what is longitudinal wave in separate question for 1 mark. Okay. So first of all, we will discuss about transverse waves. These are important according to your syllabus. These waves are explained. Okay, these are on the basis of this only, transverse and longitudinal. We are going to discuss all the things in this chapter. Okay, so the first transverse wave, I'll write here transverse wave. Very important. Okay, and very simple also. The wave in which, I'll write here, see, the wave in which particles of the medium particles of the medium vibrate perpendicular or right angles to, and right here both perpendicular or right angle to the direction of wave propagation. Very important, the word here perpendicular or right angle to the direction of wave propagation. Very simple, you can see here. Transverse wave. Transverse wave is defined as the wave in which the particles of the medium vibrate. Okay, vibrate. Okay. Why we are calling it as vibrate? Because we are classifying this wave on the basis of vibration. That's why. Okay. So the wave in which the particles of the medium vibrate perpendicular or right angle to the direction of wave propagation. This is called as what? Transverse wave. Okay. Transverse wave. Example, light waves. Or you can call water waves also. Water waves or waves on a string. Waves on string. These are the examples of transverse wave. The wave in which the particles of the medium. Okay, what is meant by wave? Simply the disturbance in the medium. Correct? Disturbance in the medium is called as wave. Okay. So here the wave in which the particles of the medium vibrate. How they vibrate? Perpendicular to the direction of propagation of wave. Okay. Suppose wave is propagating in this direction, that is like this. The wave is moving in this direction. The particles are vibrating perpendicular to the direction of propagation. This is the direction of propagation, and here the wave will move like this. Okay, so here all the particles are moving perpendicular. What is this angle? 90 degree. Yes or no? This is the direction of propagation of wave, and this is the vibration of the medium or the particle. So this and this, how much angle it makes? 90 degree. Correct? No? Like this. How much angle it makes? 90 degree. Correct? Yes. So here light waves, water waves, waves on a string. Water waves you can imagine very easily. Suppose still water is there. Still water means the water is not moving. The surface of the water is not moving. It is still. Correct? If you drop a stone in the middle of the water, what will happen? The wave will move towards the end. No, like this. Yes or no? So here wave is moving in this direction, and look at the direction of the water particles. They vibrate. Yes or no? They go up, down, like this. Correct? So here the movement of the water medium is it perpendicular to the direction of propagation? Yes, it is. That's why it is called as what? Transverse wave. The wave in which the particles of the medium vibrate perpendicular to the direction of wave propagation. That is nothing but what? Transverse wave. these waves makes important. Okay, from here it's all important. Okay, you write down it all and make all the points in your notebook. Okay, so here this wave makes, this means this wave produces crest and trough. Crest and troughs. Okay. Transverse wave makes crest and troughs. Means alternately. Okay, alternate. One crest, one trough. One crest, one trough. I will show that. This wave, very important. Keep in mind, this wave produces crest and troughs. Crest and troughs. Okay. I will show here how. Suppose this is positive x direction, correct? Positive x direction. This is y axis. You can say y axis also, and this is x axis also, correct? So here wave, okay, wave, transverse wave is like this, correct? So here, whatever these points are there, this, here, and this. These are called as the highly, okay, see here, the highly raised part, raised, okay. If I ask you to raise your hand, what you will do? You will do like this, no? Correct? Up, okay. So here the raised part of the wave, raised part, okay. The raised part of the wave is called as crest, okay, right here. This is called as crest. These both, this, okay. This is called as crest. These two are called as crest. This is also crest. This is also crest. Crest. C-R-E-S-T. Crest. Okay. The highly raised part of the wave is called as crest. Correct? Similarly, can you construct a sentence for this? This is what? Highly raised. This is what? Highly raised. This is what? Highly depressed. Correct? No. Highly depressed. Correct? The highly depressed part of the wave is called as trough. The depressed part of the wave is called as trough. Okay. These whatever are there, no? These two, this and this are called as trough. Okay. And whatever this is there, these are called as crest. I hope you can make difference in this. Okay. So these two parts which are highly raised, okay, the part of the wave which is highly raised is called as crest, and the part of the wave which is highly depressed is called as trough. Okay, very important. These are the basic information or basic terms which involve in wave. Okay. If you consider a wave means one part is highly raised and the other part is highly depressed. Correct? So this kind of wave is nothing but your transverse wave. Transverse wave, the wave in which the particles of the medium vibrate perpendicular to the direction of wave propagation. Correct? So here this transverse wave makes crest and trough alternately. One crest, one trough, one crest, one trough, one crest, one trough, like this it will go on. So here the wave is moving in positive x direction, correct? This is positive x direction, and the medium is vibrating perpendicular to the direction, correct? This is vibrating upside and this is vibrating in negative side, downward, correct? So both here, both the particles of the medium vibrating perpendicular to the direction of propagation. This is the direction of propagation, correct? So this is the direction of propagation and the particles are vibrating like this. So what is the angle? It is 90 degree. Okay, this is the direction of wave propagation and this is the direction of vibration of the medium, correct? Correct. So this is what? Transverse wave. Transverse wave makes crest and trough alternately. Okay, so here once again we will deal in detail with this. So this is the basic idea about what? Transverse wave. Transverse wave. Next we will go through the longitudinal wave. Yes, longitudinal wave. Yes, I hope it is clear to you. So I will make small changes here only, but you write down it separately. Okay, so here I will remove this now, transverse wave, and I will write the second one, and that is what? Longitudinal. Longitudinal wave. Longitudinal wave, correct? So earlier it was transverse wave. In transverse wave, the particles of the medium vibrate perpendicular to the direction of wave motion or wave propagation. So in longitudinal wave, what happens? In longitudinal wave, the wave in which the particles of the medium vibrate along the direction. Okay, here only the change is here. The wave in which the particles of the medium vibrate along or parallel to the direction of wave propagation. This is important. Along, okay, along and parallel to the direction of wave propagation. Longitudinal wave is the wave in which the particles of the medium vibrate along the direction. Okay, along the direction. Okay, that means like this, along the direction or parallel to the direction of wave propagation. Direction of wave propagation is called as what? Which kind of wave? Longitudinal wave. Longitudinal. Okay, the wave in which the particles of the medium vibrate the wave in which the particles of the medium vibrate along the direction of wave propagation. Along the direction of wave propagation is called as longitudinal wave. Here you can write along or parallel. No need to write both the words. No need to write both the words. You can write any one word. In previous case also, you can write right angle or you can write perpendicular. Choice is yours. Okay, don't write both. Okay, so here longitudinal wave. Once again, see the wave in which the particles of the medium vibrate along the direction of wave propagation. Along the direction of wave propagation. Correct? So here examples of longitudinal wave are sound waves. Sound waves. Whatever I am speaking, yes, whatever I am speaking, that is nothing but sound energy. Sound, correct? And sound is also kind of wave, correct? Sound is also kind of wave. I am speaking here and you are listening to your ears, correct? So here whatever the sound is there, whatever the wave is there, it comes to your ear. in the form of longitudinal wave. In the form of longitudinal wave means whatever the particle, whatever the medium is there between me and you, correct? Whatever the medium is there in between us, medium is there. Air medium is there. Yes. So here air medium, the particles of the air medium vibrate along the direction of wave propagation. Okay, along, correct? Along or parallel to the direction of propagation means like this. They will vibrate like this, like this, like this, and they will come to your ears. Correct? If they will not move like this. Okay. Longitudinal wave will not come like this. Okay. So here the particles will vibrate like this, like this, like this, and they will come to your ear. Yes. So sound waves, sound produced in air columns. You might have seen again that whatever flute, you might have seen flute. So whatever the waves will produce in that flute, that is also a kind of longitudinal wave. Longitudinal wave, correct? So here, if the transverse wave makes crest and troughs, if the transverse wave makes crest and troughs, then what longitudinal wave makes? Then what longitudinal wave makes? Let us see that. Yes. So here this wave means longitudinal wave. This wave means longitudinal wave makes, or longitudinal wave produces or makes rarefactions and compressions. Important new words: rarefaction. Okay, rarefaction and compression. Compression means compressed. Okay, tightly packed. Okay, rarefaction means the word itself says rare. Rare means what? Rare. Okay, means very less. Rare means very less. Okay, so here how this wave looks. How this wave looks, let us see. Okay, I'll try to draw here. I hope you can able to distinguish this. Here you can see, here whatever the particles are there, this is the direction of wave propagation. This is the direction of wave propagation, and this is the mode of vibration. These are vibrating like this, like this, like this, like this. Okay, so here we can see all the lines are parallel. All the lines are parallel. Okay, so here what happens? So here this whatever there, these whatever the lines are there, these are nothing but lines, are nothing but your medium, particles of the medium. Here the distance between these parallel lines are more. Yes, parallel lines are more, and these here, and here, the line, the separation is more. I will try to draw here one more. It looks almost same, okay, but you should be able to classify this. Okay, draw once more. See here. I hope now you are able to imagine this. Yes. Yes. So this is nothing but your which kind of wave? Longitudinal wave. Longitudinal wave. Here, can you see here these lines? These lines, the separation between these lines is more, correct? These are called as rarefactions. Rare. The lines are rare, correct? So in this, okay, in this region the lines are less, and in this region the lines are more. The lines are more. So here, whatever these are there, this is called as rarefaction. This is called as rarefaction. I will write here. These are rarefaction, and here, see here, these lines, whatever these lines are there, they are very close. Yes or no? Compared to these lines are very close to each other. Yes, close means compression, correct? So this is compression, and here again rarefaction. The lines, the separation between the lines is more, correct? Try to imagine. Okay, try to imagine here. The separation between the lines is more, here less, here more. Okay, here again less, that is, this is compression. Okay, I will write, this is compression, this is rarefaction. R for rarefaction, C for compression. Same, rarefaction, compression, rarefaction. This will continue. This will continue. Correct? So here this kind of wave is called as longitudinal wave. I think it is a little bit difficult to imagine you, but you can understand this, no problem. Okay, so the rarefaction. Rarefaction means here the pressure is less. See here, there is no pressure. There is no pressure. That's why they are okay, little bit far from each other. Yes, but here the pressure is more. If you apply pressure on anything, what will happen? Compression takes place, correct? No, compression takes place, correct? So suppose here, if you have a rubber eraser, if you have long eraser, suppose, if you compress it, or if you press, or if you give pressure from both the ends, what will happen? Its size decreases or increases? Yes, obviously the size will decrease. Yes or no? So decrease means here decreasing. Here compression takes place. That decrease in the size is nothing but compression. It is nothing but what? Compression. And if you again stretch, if you hold, okay, if you hold the ends of the rubber and if you give pressure outward, what will happen? Rarefaction will take place. Its length will increase or not? Yes. So here length is increased, length is decreased. Increase, decrease, increase, decrease. Like this, it will go on. Okay. The place, okay, the place where the pressure is more, correct? Where is the pressure is more? Here, this side. Okay. That means high pressure makes compression, and low pressure makes rarefactions, correct? Low pressure, high pressure, low pressure, high pressure, low pressure, high pressure. Okay, so here pressure is very important. Because of the pressure, rarefaction and compression takes place, correct? Because of rarefaction and because of compression. Okay, so that means what? Here the pressure is low. Pressure is low. That's why the separation is okay. Separation is there. Here pressure is large. Pressure is large. That's why all the lines are coming close. Okay. So here this is called as compression. Rarefaction, compression. Rarefaction, compression. Rarefaction, compression. So this is about what? Longitudinal wave. Very important. Very important. Okay. What are longitudinal waves? The waves in which the particles of the medium vibrate along the direction. You can see here. They are vibrating like this. Along the direction of wave propagation. The wave is propagating in this direction. Correct? In this direction, and the vibration of the particle is also in the direction. okay, or along the direction of wave propagation. That is called as what? Longitudinal wave. Longitudinal wave. Okay, these are sound waves. These are sound waves like this. Whatever I speak, it will reach in this form: rarefaction, compression, rarefaction, compression, rarefaction, compression, like that. Correct? I hope you got this. Okay. So today we have discussed about transverse wave and longitudinal wave. Correct? So they may ask this for 2 marks: distinguish or write the difference between longitudinal wave and transverse wave. Okay, then in that case we will see differences. How to write differences between longitudinal wave and transverse wave. Okay. Right here. Transverse wave one side, and here we can write longitudinal wave. Longitudinal wave. As we have discussed, what are transverse waves? The waves in which, okay, I will not write in detail, okay, just I will talk in detail, but I will write in short. Okay, so this is transverse and this is longitudinal. The first difference is what? The particles of the medium vibrate perpendicular to the direction of medium. Okay, I write here particles vibrates perpendicular to the direction of wave propagation. Wave propagation. Okay, same here. The first difference is what? The particles of the medium. Okay, particles of the medium vibrate parallel or along the direction of wave propagation. Correct? Yes. They form crest and trough. They form crest and trough. Here they form what? They form rarefaction. The word, okay, these words are new to you. Okay, remember this: rarefaction and compression. Rarefaction and compression. Okay, the third one is they can be polarized. They can be polarized. Okay, here they cannot be polarized. In next year you will study this polarization. Okay, polarization. They can be polarized, they cannot be polarized. Yes. Next example you can write. Example of transverse wave is light waves. light waves. You can write fourth, that is example, sound wave. For 2 marks it is enough. For 2 marks it is enough. So see here, in this class we have discussed about very important concept, that is classification of waves on the basis of vibration. So on the basis of vibration, waves can be classified into two types, that is transverse wave and the second is longitudinal wave. Transverse wave and longitudinal wave. Transverse waves are those in which the particles of the medium vibrate perpendicular to the direction of propagation of wave. Correct? And in longitudinal wave, the direction of wave propagation, or the wave in which the particles of the medium vibrate parallel or along the direction of wave propagation, is called as longitudinal wave. Correct? So here transverse wave makes crest and troughs, whereas longitudinal wave makes rarefaction and compression. The highly part of the wave is called as crest. Correct? The highly raised part of the wave is called as crest, and the highly depressed part of the wave is called as trough. Keep in mind, crest, trough. Okay. Similarly, longitudinal wave makes rarefaction and compression. Low pressure makes rarefactions, and high pressure makes compression. Makes compression. They can be polarized, and these longitudinal waves are not polarized. They cannot be polarized. The example of transverse wave is light waves, and the example of this longitudinal wave is sound wave. I hope it is clear to you. In next class we will again discuss some equations, some important definitions of waves. What are the components of wave? Those are very important. Those we will study in next class. Till then, you study this. Be safe. Thank you.